Greetings to the viewers, classmates, fellow batchmates, and teachers. I would love to introduce myself. I'm Sharmell Malapitan.
I am Ralph Miguel Garcia. Today, we would address our presentation about derivatives and the roots that expanded through our latest lessons. But we would focus on the focal point, which is the theorems.
The derivatives consist of 6 theorems, namely constant rule, power rule, quotient rule, chain rule, product rule, and sum or difference rule. First up, Theorem 1. It is also called the constant rule, that in any constant value without the support of the variable is equivalent to always 0.
For the first example, we have y equals 5. And using the constant rule, let's have y prime equals 0. And that's our answer. For the second example, we have y equals 3 over 5. And y prime equals 0. Using the constant rule and the formula, that y prime equals f of x equals 0. For the third example, we have y equals 5. And pi equals 3.14. And using the constant rule, we have 0. Because we consider this as our e. For the third example, we have y equals e. And e is equal to 2.71. And y prime equals 0. For the last example, we have y equals square root of 3. And using the constant rule, we have y prime equals 0. And that's our answer.
Secondly, Theorem 2. It is the sum or difference rule. Any constant that is supported by a variable should drop or exclude a variable that isn't supported by an exponent.
For the second theorem, if y equals f of x equals k x raised to 1, then y prime equals k. For the first example, we have y equals 12x. Then using the sum or difference rule, y prime equals 12. Because x will be removed according to our rule. Then number 2, y equals 32 over 53x. And using the theorem, y prime equals 32 over 53. And that's our answer. Then for the third example, we have y equals negative 18 over 23x. And like the number 2 example, y prime equals negative 18 over 23. This variable will be removed according to our theorem. And for the fourth example, we have y equals square root of pi x. And using the theorem, we have y prime equals pi square root. Then for the last example, we have y equals 12x plus 4. And using the rule, y prime equals 12. And according to our theorem 1, the 4 will be removed, and using the theorem 2, the x will also. This is our final answer.
Proceed to theorem 3. It is the power rule, or I should call it an enhanced theorem 2. When the variable has an exponent that is greater than 1, we are expecting to multiply to the base number and deduct to the original exponent to 1.
Now let's move on to theorem 3, which is the power rule. If y equals x to the power of n, then the y prime should be equal to n times x to the power of n minus 1. So we have our example here. Y equals 5x squared. So we should consider y prime, then substitute 5 to multiplied by 5, which is 10. Then minus the exponent to 1, which is 2 minus 1 is 1. Basically, imaginary 1 for the exam. So we have an answer, 10x, right here. Next, y equals negative 16 over 32x cubed. Since 16 over 32 is multiple with each other, they should be expressed in lowest term. So 16 times 16, or 16 plus 16 rather, is 32. So basically, we should end up with 1/2. 1/2 x, copy pa rin, negative 1 of x. Then we should apply the power rule now then on the lowest term. Then we should end up with 3 halves x squared. Next, let's proceed to example number 3, which is y equals negative 96 to the 5th power plus 4. Basically, we need a calculator for this to be certain for our answers. So consider the power rule. Y prime equals 5 times negative 26. 5 times 26 is 130. 130. X, 5 minus 1 is 4. So, to the power of 4. Drop the 4 because constant rule, as based on the theorem 1, is 0. And we have an answer. Easy as that. Next, let's proceed to example number 4, which expresses y equals 6 over 5 x to the 8. There will be no needed to round it off because it is in proper fraction, unlike this one, because they are common to each other. So we should consider y prime express 8 multiplied by 6 is simply is 48. 48 over 5. And 8 minus 1 is 7. So 7, they have no need to round it off because they are not common to each other. If it's 45 over 5, then we should express this in 5 and 9 like that. But it's in 48, so there's no need to round it off. So that's the final answer.
Theorem 4 is something else. It is the product rule. It is a complex one because you have to consider the first following rules to solve for theorems 4 and 5. Why complex? You have to consider taking the first term derivative and the second term derivative and substitute it using the formula.
So we have theorem 4 here, which is the product rule. So we have our formula, derivative of the first multiplied by the second plus derivative of the second times the first. So we have our problem here, which is y equals x to the 4th power plus 4 multiplied by 3 minus 4x. So we should consider taking our formula, which is the derivative of the first, using theorems 1 to 3. Para hindi muna tayo malito, gamitin muna natin. We should apply f of x muna, f prime, for the derivative of the first. We should consider this first and the second. So basically, using our previous theorems, drop the 4, power rule, 4x, third power. Then we should consider the second derivative, which is considered here. G, drop the 3 because it's a constant. Constant is 0. And drop the variable because of theorem 2. 4. So if we would substitute 4x cubed, let's copy the second. 3 is 4x. Copy here. Multiply 4. And then the first. The first is x to the 4th power plus 4. And then we should substitute. Distributive property, using the distributive property, 4 times 3 is 12x cubed. 4x cubed times 4x, 12x cubed, then multiply 4x cubed times negative 4, so negative 16x cubed, then 4 times constant pa rin, 4 plus 4x. The 4th power is 16. Combine like terms, so we have negative 4 square power plus 4 power is 16. Iayos na lang natin. 4x to the 4th power minus 4x cubed plus 16. Yeah, answer.
Theorem 5 is also a complex one. It is the quotient rule. Maybe we should say the antonym of the product rule. Like the product rule, you should get first the derivative of the two terms before substituting it into your problem. But instead of using first and second terms, we'll utilize the elements of fraction, the numerator, and the denominator.
For the fifth theorem, we have y prime equals denominator squared, denominator times the derivative of numerator minus derivative of denominator times numerator. And that's called quotient rule. For the first example, we have y equals 3y squared plus 5 over 4y plus 3. Let's first find the derivatives of numerator and denominator. For the derivative of numerator, we have 6y. Considering the theorem 1 and theorem 2, multiply. Then for the derivative of denominator, we have 4y. Considering the theorem 2 and theorem 1. Now, let's consider the formula. Y prime equals denominator, which is 4y plus 3 times derivative of numerator 6y minus derivative of denominator, we have 4 times numerator 3y plus 5 over 4y plus 3 squared. Now, let's distribute this given. So 4y times 6y equals 24y squared. Then 6 times 3 is equal to 18y. Then 4 times 3y is equal to 12y. Then 4 times 5 is equal to 20. Denominator squared. Then combine like terms. And 24y squared. 18 minus 12, we have 6y plus 20 over 4y plus 3 squared. And that's our final answer.
We'll now conclude our presentation for today. We hope that you had fun carrying out the problems we've addressed all throughout the discussion. Remember, math is a lethal weapon. It is either you use it as a weapon or it will be used against you.
See you next time, Pythagoreans!